George just completed a test on a sample of material from a new synthesis. The phase separation is just as predicted. George logs in the results, and then he calls the production supervisor. With these results, they can continue with phase 3 of the project. This test wraps up phase 2. George knows he's not finished with this procedure just yet. That black goo in the bottom of a centrifuge tube, that's residue from the test, a mixture of reagents, solvents, and reaction products. It's just a waste with no further value, but at the same time, it's a serious responsibility for George and for the lab, because that residue is a hazardous waste. And while it's just a small amount, remember, there are thousands of labs and research facilities all over the country. Every few grams poured down a sink or tossed in with the trash adds up to a serious potential threat to human health and the environment. For George, there's no hesitation. The hazardous residue is precisely identified and categorized, then promptly assigned to the proper hazardous waste accumulation container. You see, every summer, George and his family go camping with friends up at the lakes. So it figures that George takes every precaution to keep that black goo out of the streams and lakes they all swim and fish in. As scientists, researchers, and technologists in a laboratory or research facility, you assume a high level of responsibility in your work. You take on a problem, gather samples, supplies, reagents, and equipment, and conduct a procedure or analysis. If your work produces a waste, any waste, one of your responsibilities is to take the required steps to manage that waste properly according to state and federal regulations. To do that effectively, you need to know how to identify the wastes generated and how to manage, handle, and control each to keep them out of the environment. Consider the wastes generated at a typical lab. Samples, both used and excess. Filter elements, empty bottles, bags and jars. Spent reagents, waste gels, broken glassware. Waste paper, plastic, and packaging. Most of these wastes can be disposed of along with normal trash. Some lab wastes are hazardous wastes and can cause serious damage if released into the environment. Normal trash usually ends up in a sanitary landfill. But an ordinary sanitary landfill is not designed to contain hazardous constituents in the wastes. Waste materials can leach through to groundwater and escape into the environment. Any laboratory wastes that are hazardous must always be handled separately to prevent them from reaching the local sanitary landfill. There are two primary classes of hazardous waste: listed waste and characteristic waste. Listed wastes are wastes from specific processes or wastes that contain specific hazardous constituents which have been identified by the EPA or your state environmental agency. For example, any waste containing spent halogenated solvents such as methylene chloride or trichloroethylene is a listed hazardous waste. Waste acetonitrile from high-pressure liquid chromatography is a listed hazardous waste. Some listed wastes are so dangerous that they are called acute hazardous wastes. A very small amount of these wastes can cause considerable harm to human health or the environment. The other primary class of wastes, characteristic wastes, includes wastes from any source that demonstrate any of several hazardous characteristics. The EPA publishes standardized test procedures that define 4 hazardous characteristics: ignitability, corrosivity, reactivity, and toxicity. Note that radioactive and biological wastes are not included in the mentioned hazardous waste classes. These wastes must be handled according to different regulations. If your lab generates any of these types of wastes, consult your environmental specialist. When a waste first comes into existence, in a test procedure, experiment, or a sample analysis, or as a result of a spill or an accident, this is termed generation of the waste. When a waste is first generated, it must be determined if that waste is hazardous. Once generated, a hazardous waste becomes the facility's responsibility for as long as that waste exists. The EPA calls this cradle-to-grave responsibility. The facility never loses responsibility for its waste and never totally transfers its liability to another party, not even the off-site facility that will ultimately treat or dispose of the waste. The first task in proper management of hazardous laboratory wastes is characterization. That is, determination of what is in the waste and whether it is hazardous. For wastes from standard or routine procedures, this determination may already have been done. However, where the procedures are non-standard or change frequently, such as in a university or research lab, waste profiling may take considerable work. Generally, the scientist who generates the waste is principally responsible for identifying the components present in the waste. Because hazardous wastes display different hazardous properties, and because wastes of unknown composition cannot be legally disposed of, it is the generator's responsibility to profile each waste. The scientist is responsible for developing an accurate and complete list of all known or suspected hazardous components in his or her wastes. This information must be provided to the person responsible for waste disposal. The State Code of Regulations and your facility environmental coordinator are good sources to help identify and describe hazardous wastes. All this information is needed for proper lab packing and disposal of wastes. You might think that flushing a waste down the drain dilutes it, so that it's no longer hazardous, or that throwing just a little hazardous waste in with all the other trash would be safe enough. Well, certainly flushing down the drain will dilute a waste, and a half cup of waste is just a speck in the world of trash. But they say dilution is not the pollution solution, because every dose, diluted or not, adds more pollution to the environment. And that's why improper disposal on-site is illegal. The first rule of hazardous waste management is that hazardous waste generated at the lab cannot be disposed of on-site. This means that it cannot be flushed down the lab sink, tossed into the general trash, or left to evaporate in a fume hood, unless your lab or its treatment facility is permitted to dispose, abate, or treat hazardous wastes. Hazardous waste must be collected, handled, and managed according to very specific regulations. Most labs will have a chemical hygiene plan or similar document that describes lab safety procedures, including dealing with hazardous substances. Since hazardous wastes are also hazardous substances, the CHP will usually address proper waste management procedures. When handling hazardous wastes, personal protective equipment is always required. To avoid accidental releases of hazardous chemicals or waste, make sure the procedure is conducted with proper controls. If conducting a procedure over or near a normal lab sink, plug the drain or place a cover over it. Most hazardous waste will be collected on-site and accumulated before eventual shipment to an off-site facility for recycling, treatment, or disposal. Accumulation often starts in a cabinet or at a designated area of a bench located right in the lab or research operation. These in-lab accumulation points are called satellite accumulation areas. A lab may accumulate wastes in a satellite container without any limits on how long the wastes may remain in the lab. However, a container used to collect wastes from several physically separate labs or other generating facilities cannot qualify as a satellite container and therefore is subject to accumulation time limits. Satellite accumulation must be strictly managed according to regulatory standards. Satellite areas must be under the control and oversight of the trained scientist or technician who generates the wastes accumulated there. Wastes may be accumulated in a fume hood, but should not be kept in a hood that is regularly used for lab procedures, especially if the procedures involve other hazardous or incompatible substances. According to regulations, no more than 55 gallons of hazardous waste or 1 quart of any acute hazardous waste may be accumulated in a satellite area. Each satellite accumulation container must be clearly labeled with the words hazardous waste and/or a description of the waste inside. Containers used to accumulate hazardous waste must be sturdy, in good condition, and free of leaks. If a container is ever observed to be leaking or damaged, the contents must be transferred into a leak-tight container immediately. The container itself must be constructed of a material that is compatible with the wastes inside. Original containers are often used, as are containers made from chemically resistant plastics. Satellite areas must not interfere with normal lab operations and must be kept clean and free of obstructions. Avoid locating satellite areas near floor drains or any sources of ignition. Flammable wastes must always be accumulated in a safety can or other approved container. All the wastes in a single container must be compatible. That is, they should not react, generate heat, or evolve gas. For example, you would not place waste oxidizers in a container with any organic wastes. These two wastes could react violently. Satellite areas should not interfere with normal lab operations. Emptying wastes into satellite containers should be easy and convenient. Keep the area clean and free of obstructions to prevent unnecessary reaching or contortions. Always keep containers closed, except when adding or removing waste. Lids, covers, and flapper openings should be securely closed after each use. Generally, labs should try to use a separate container for each distinct type of hazardous waste. This minimizes compatibility problems and can facilitate more effective waste recycling. It is always a good idea to place some type of secondary containment under and around satellite containers to collect any spills or leaks. A simple metal or plastic tray is often adequate for smaller containers. These containment devices must be compatible with the wastes being accumulated and must be leak-tight. These secondary containment devices should not be used for storage of any other materials, equipment, or supplies, not even temporarily. When a satellite container reaches the maximum quantity allowed, that is 55 gallons of hazardous waste or 1 quart of acute hazardous waste, the container must be dated and moved from the lab within 3 days. When wastes leave the lab, they may be shipped directly to a specially permitted off-site facility for recycling, treatment, storage, or disposal. Or, more commonly, they may be sent to a central on-site accumulation area. Central accumulation is normally under the supervision of environmental specialists who manage the accumulation, lab packing of smaller containers into larger containers, and shipping to a permitted off-site facility. In the central accumulation area, wastes will be held, along with wastes from other on-site labs or other generating areas of your operation, for later shipment to an off-site treatment facility. The length of time that wastes may remain in the central accumulation area depends on the total amount of waste that your entire operation generates. Ultimately, your hazardous laboratory waste may only be shipped to a facility that has been permitted by the state or EPA to treat, recycle, store, or dispose of your type of waste. These facilities are often referred to as TSDFs. Each TSDF has an analytical lab that checks to make sure all required information about the hazardous components in each incoming waste is correct. At the TSDF, lab wastes may be recycled and valuable components recovered whenever possible. When recycling is not feasible, organic wastes can be burned for energy recovery. Other organic wastes may be incinerated or treated in some way. As a last option, wastes are deposited in secure, specially permitted, leak-tight landfills. From the beaker to the drum to the TSDF, throughout generation, identification and profiling, and accumulation, it takes accurate information and careful handling by concerned, knowledgeable personnel to keep hazardous wastes completely controlled. It's up to all of us to see that all laboratory hazardous waste, like George's black residue, is safely delivered for recycling, treatment, or disposal, and never encountered up at the lakes.